Okay, so this is the first session of the training, starting with the KNX integration. So we will start with a presentation to explain why is the BMS the most important tool if we have a massive KNX project. Or even not massive, but also like a project with several lines to integrate. It's very important to understand that we have different different possibilities to do this integration, but only a few of these possibilities are the best to do this integration. If you have several lines in a project, we can do the implementation of these projects in different ways. I will show you some scenarios to do this configuration. One of these is the classical scenario. It's a typical twisted pair lines in KNX technology, linked together using couplers. TP couplers means that we have copper cable in both sides of the coupler. This means transceiver, connected to both sides of the coupler. So it means that we need power supplies in every of the lines. In these examples, I just have I represent 6 lines of one single area, but I will try to explain how difficult it is to do this integration if we need to supervise, if we need, for example, a visualization, classical visualization and control solution for this, let's say, medium-size project with 6 lines, we can have very big problems if we don't focus the project properly. Why I'm saying this? Because we have a traffic in terms of telegrams per second we have to manage, and this is normally invisible in many projects, but it's very important because even if we can configure filter tables properly to just maintain the traffic in every line and independently from the rest of the lines, we will need all the traffic in the main line. This is because of this visualization and control access method. The access method of these softwares are typical using the Falcon driver that KNX gives. Falcon driver means just one point of connection to the system. So in terms of a multi-line project, it has to be decided where is that point of connection, that connection point for our supervision system. We have to understand that the bigger is a project, the most important is that supervision, because we will have a lot of devices, a lot of signals, a lot of elements that can be under some troubles. We have to supervise the connections. We have to supervise all the data points. And when the project is more and more extends, more big, it's more important, this visualization and control. So it's important also to realize the integration of the signals and all the aspects related to this integration. So in this image, you can see very easy how is the traffic in this in every single line. So considering that we are doing a good job in the filtering, using manual editing of the filters or using dummies, for example, in the main line, we will have a lot of traffic in this main line. This is because of this supervision system that is necessary in this kind of projects. So it's a problem when we have this kind of solution, this first classical configuration with using TP couplers, because there is a limit in terms of telegrams per second in one line, and this limit in theory is about 40-45 telegrams per second, but in practical it can be no more than 10 and 12 telegrams per second, because we have to reserve some bandwidth for programming devices. So it's really a problem when we have a lot of traffic added in this main line using this configuration. And then we can think about, okay, it's not a problem because we know that we have IP routers, couplers that has an IP backbone in the main line, okay? And this is just the next scenario. And we may think, okay, Julio, it's not a problem because we can have 1,000 times more bandwidth with using an IP network. First of all, we have to understand the different services that an IP backbone or the KNX Net IP protocol is offering us in terms of ways to connect to the system from an outside device, from the ETS, for example. We have the routing configuration that is normally necessary because in comparison with the previous scenario, we do not have electrical continuity in the backbone in this case. So this is important to simulate this kind of electrical continuity in terms of sending from one line a telegram through the rest of the lines. In this case, it has to be solved in a different way than from the previous scenario, because we do not have this electrical continuity. In the previous scenario, when a coupler sends a telegram, it just reaches all the rest of the couplers in the main line by a natural electrical continuity, but we do not have this electrical continuity. So this first service, this first kind of connection, the routing multicast, is helping us to do this, to solve this issue when we use a IP backbone. But we have a problem. It's not a problem with the bandwidth, but remember that all these KNX couplers have a memory that is used for two things. The couplers need a memory for the filter tables, so to decide what kind of telegrams are interesting to cross through the couplers, but also part of the memory is used for a buffering of telegrams, because memories has to be very fast in terms of analyzing telegrams, but cannot analyze in real time if the traffic is so high. So we have this kind of buffers for both directions of the communication. So in this scenario, even if we have a big bandwidth using IP backbone, we have a problem with the bottleneck in the couplers because of these buffers. So it's invisible again, but using IP routers is necessary, but it's not enough. So it's important to consider, okay, we have a lot of lines, we need IP couplers, but the routing multicast communication is not the best one. So we go to the next scenario. What we need to do is to ensure the best performance in the project, in our installation. The best connection is the tunneling connection. It's not a global solution for the communication. It's just a local solution. It means that from outside of the line, we can access directly using this tunneling connection. For example, the ETS can do a direct connection to this line, to line number 1 or line number 2, etc. But with the ETS, we can only use one driver, one connection. This is the limitation of the Falcon driver I was telling you before. This Falcon driver is only one point of connection. So what is the solution from the BMS platform, NETx Automation BMS platform? We are providing simultaneous tunneling connection to all the lines in the project. So this is our third scenario. We can solve the issues related to the traffic very easy, because in a huge installation, imagine that we can connect or we can, with a BMS platform, we can do 1,000 connections simultaneously. So the project can be really huge with no problems from the point of view of the software. The software is connecting directly to the lines, and this is avoiding us problems with the routing communication, because we do not need to edit filter tables. We do nothing with the filter tables, just make them filtering to have the normal traffic that has to cross from line to line, that it's really a very small amount of traffic, sometimes even zero in some projects, no traffic from between the lines. We have not necessary to edit filter tables. We don't have any problems with the bandwidth because of this IP configuration, and we do not have any coupler bottleneck, any at all, because there is no traffic almost in the main line, and this is because the BMS platform will connect simultaneously using tunneling connection. Okay, so this is very important because this opens other possibilities for us. The items for the BMS will be the combination of this tunneling IP address that is in green color in the screen, different from every line. You will see in my practical boards that I have 8 different lines with this IP configuration: 199.168.71.12, 22, 32, 42, 52, 62, 72, and 82. This is the final numbers of these IP addresses. So I have 8 different installations, totally different. And this is interesting because it can change our mind in terms of thinking on a project. Maybe also helping to simplify the projects at all, really in an extreme way sometimes. So this is what I was telling you about the global vision of a project. When you have a BMS platform, NETx Automation BMS platform, in combination with a huge KNX installation, you have to think globally for the project. Sometimes we have to change the way that we consider the topology in terms of KNX, considering maybe not interesting to have a different lines and areas. And with the fourth scenario, I will explain better, I think, because there is another way to explain this. First, prior to show you the fourth scenario, just to mention that the item, all these items from KNX lines will be mapped. We can say there will be a mapping of this element, and they will appear in an item tree where you will see an XIO. XIO branch means that the native drivers of the BMS server will be included here, KNX or BACnet or whatever you will see. But in an XIO branch, you will have a KNX branch. And this KNX branch will include all these tens or hundreds of lines. And each line will include our data points in terms of group addresses or even physical individual addresses. So for us, our items IDs will include our IP address in terms of the name of the gateway, okay, and then the group address or the physical address. So this is helping us to think different way to solve projects, to face different projects. For example, we can have exactly the same programming in the different KNX parts of the project, because for the BMS they will be different thanks to the different IP tunneling address they will have. So I mean, every single group address in each of these lines could be exactly the same for each line. Every single physical or individual address could be also the same for all of these elements. And in fact, in our practical boards, we have exactly configured the same way all the devices and all the group addresses. They are identical installations, but all of them are integrated thanks to the BMS platform in one solution. So this is helping us to simplify a lot a project, because we don't have to think about different lines, different topologies, one big ETS project to integrate everything. It can be simplified massively, so radically. So it's very important for us to think in this way. these kind of solutions can help, for example, to have 200 retail stores or 5 or 50 identical floors in a building. In fact, we have done some examples in Spain with this kind of way of thinking in terms of programming exactly the same way every floor in a building, and then integrate all these, in this case building in Madrid, 68 floors exactly the same way using the BMS platform, because for the BMS the items will be different, because the IP will be different for each small branch of this KNX branch in the item tree. Sorry. So, and on other hand, we are using the tunneling connection. So this means that we maybe don't need the routing multicast connection. So there are specific devices in KNX that are the IP interface, not IP routers, the IP interface that only provides tunneling connection. For us, they are enough. In many projects, we do not need routing multicast. In some cases, because it's forbidden by the IT responsible. The IT department says no routing because of safety rules in the company. Only tunneling is permitted. So we can solve this situation because we are using the tunneling connection. And we do not need to spend a lot of money in terms of devices, because we just need an IP interface. Okay, so this is the fourth scenario. We can replicate exactly the same configuration in all these parts of a building. For example, imagine a hotel with 500 rooms. In extreme configuration, it can be exactly the same configuration for each room if the rooms are identical, and you do a very small ETS project. You implement 500 times this ETS project, and you will only need exactly one IP interface for this project, and the integration will be very easy. And this is also adding security for your project, because it's impossible that from one room you can control different rooms as an end user. So if an end user can plug in the KNX TP line of his room and tries to sniff the traffic of the telegrams, many integrators we can do it. And try to turn off the lights of the neighbors and whatever, it's not possible because they are isolated. So this solution is also improving security. We have some documents explaining, some white papers explaining this, but it's interesting to understand this scenario. Even we have a last scenario where if you have an old installation, you can solve this kind of issues in integrating the normal couplers with the IP tunneling connections, and then integrating an old installation, solving all the traffic issues, just adding an IP interface in every line in parallel to the normal coupler, and then integrating with a BMS. So finally, just to show you the layout of my practical boards, we have some practical boards here, 8 practical boards representing in this training. We will, as an example, show a hotel integration, but just an example. It could be an office building or a mall or an airport or wherever, but this is the same. And as you can see, we have different rooms for floors, just 2 rooms per floor, because there is a complicated to have 100 practical boards to show, but it's enough to show you the power of the BMS and the easy way to configure everything. These rooms have just lights and shutters, we can say, some temperature from the thermostats. But the most important thing is that we have configured exactly the same way all these devices. It's a very small ETS project, so we will integrate these, let's say, rooms from the hotel with one single project. So we will integrate it as different projects. It's also possible to integrate different projects in our BMS, just considering the proper network configuration. Okay, all these devices, of course, are in the same network. It's also the same network than my home. That I am speaking from home, and my home has also a lot of KNX integration. We'll show you some DALI integration in next sessions. And this is the devices we will use for KNX. Okay, we also have another device that can help us to see BACnet and Modbus and SNMP integration in principle, with some binary inputs, some binary outputs, analog inputs, or whatever. So this will be just an example, a device to show you BACnet integration, for example, with another devices we can also integrate to increase the protocols that we can integrate in these examples. Modbus will be also in the Modbus also integrated in several ways. And finally, finishing the presentation, showing you the contacts. You will have this presentation also in the documentation. You will have our contacts to contact us. But the first practice, or the first part of the training, will be the real integration. So I will close this presentation. Real integration from KNX to the BMS platform. Okay, so let me show you these small ETS projects, just as a first approach. This is exactly the configuration we have. Devices I have shown you in the picture, push button, binary actuator. In principle, we are interested in the circuits we are configuring. So most important things for me is the actuators, binary actuators with 8 lights, shutter actuator or blind actuator, dimmers, two dimmers, a classical dimmer and a LED driver, a presence detector that also is giving us just the illuminance, and one IP interface. Okay, just one IP interface, not IP router, one IP interface. In fact, it is not the 0 element from the line, it's just the IP interface with the IP configuration here. We will provide you all these projects, all these files we are generating, because it may be interesting to you to take this and try to do exactly the same practice in simulation mode, of course, but you will have all of this, no problem. I said before that all these resources, not only the videos, but also the practical resources, the practice will be in the Dropbox. Okay. So some DALI devices, because there is a session very interesting about the lamps module. So we have some, it's in simulated devices. We don't have these DALI gateways per room, and maybe it would be a very big room if we have to get DALI gateways. But just to explain you how easy it is to manage a massive amount of DALI ballasts. One is from different manufacturer than the second. One is ABB, I think, and the second is Schneider Electric. So you will see how easy it is to integrate it in the lamps module. Okay, so this is just the layout, the ETS project. Imagine that you have programmed properly this project. We only need to do this, the following thing. We need to have an ETS app that is for free. So just if you want to do the practice, you will need an app that is this NETx BMS App Secure. Okay, NETx BMS App Secure. And then the only thing to do is to check the IP configuration. Imagine this is the first room. Okay, the IP configuration is here. The IP is correct. Okay, in this case, it's a static IP address. It's important to know what are the IP address of these devices. It's also very important, this name of the gateway. I repeat, it's very important, because if you don't change the name of the gateways, you will get all the gateways with the same name in the BMS platform, and this is not good, because part of the item ID is this name. The IP is substituted by the name of the gateway. So it's very important to change this if you're going to create different files exporting from this app for every of the rooms. That is the example I will show you. We will not have, as mentioned before, one big ETS project. We will have just small ETS projects, in this case the same project, exported 8 times. Okay, we have these files already exported, so I will not need to do it 8 times, but I will show you the process 2 or 3 times. But the question is very important to consider the name of the gateway from one side. Okay, change the IP for every single part of the installation, and then also the name of the room. This is just for the lamps module. Okay, the name of the room is also interesting to be changed every time we export. So we have a small project, and I will export 8 times this project. So this is the first step. Considering that the ETS work is correct, is already done, you have the right configuration of the devices with status, with central functions, whatever you may need. We just need to send this information to the BMS. What is the way to do this? In KNX, we do this integration of KNX in the BMS platform using this app. Okay, so okay, I have installed the app. It's very easy for you to install an app. You just need to see the typical configuration for an ETS app. And then after checking all these IP configurations, just select to which server we want to export. So we have 2 new tools, BMS platform. The multi-protocol server is the same tool, but without management, without database, and without visualization. So it's almost the same for the 3 first sessions, but not for the rest of the training. I will select the BMS platform. BMS server 2.0 is the old version that is not supported or not explained in the training. So to install the app, somebody's asking, you just have to go to the app configuring ETS 5 or 6. It's also for ETS 5, okay? So you go to settings, ETS apps, and then you have to download 2 things in the app. You have to download the file, ETS app file, after you are purchasing for free. It's for free. ETS app file from your account in KNX, in my KNX account. Okay, and also you have to license this app for your dongle, for your license. It's very easy. It's explained in the website as Aksai is telling you. So I will not invest more time in explaining this, because it's a trivial thing. Okay. So selecting BMS platform, we have different possibilities, as you can see here. But the basic things, let's say, I will not select anything that the minimum thing. This is the mapping of all the group addresses that are below every single KNX net IP interface. In this case, I am using KNX IP interface, not routers. Okay, I don't have, because I don't need a routing integration. Okay, this is the minimum thing. The mapping is okay. The ETS app, the NETx BMS App Secure will be doing this mapping, which group address is below which IP interface. In this case, there is only one line, so there is no difficulty for the app. In case of having a big ETS project with several lines, it will be checked which device is in every single line, and then applying this IP configuration with inside this mapping. The mapping is the name that resumes all this configuration. Okay. So another possibilities is to have a device monitoring in commented mode. Device monitoring means the physical address of the devices included in the installation. This is very interesting also for a traceability of the bus. If you want to know if there is some issue with devices, this is intended for this. It's also possible to know if one specific actuator or push button or whatever is still connected to the bus. Okay. And then this topology view, buildings view, traits, and all devices view are for another way to see the project is in terms of objects, not in terms of group addresses. This is a possibility to include the buildings view, for example, and then you will have exactly the same mapping, but from the objects point of view. For example, if you have a binary with channels like we have here, we don't need to know which is the group address that is connected to the channel number one, because we will have the object that is connected to these addresses. So you can use the object instead of the group address. To simplify the explanation, I will not include all this information because there is a lot of information included in this kind of buildings view or topology view. Okay, but it's important to understand that we have the whole possibilities. We can extract all the information from ETS and include it in our project, in our BMS. And finally, the lamps is for the lighting management. Lighting management in terms of DALI, for example, in terms of any lighting circuit management. So it's important if have DALI, as we are trying to simulate that we have DALI in our installations, to export lamps. It's not a problem to include it now. So this is the basic configuration, by default configuration, that I will respect in this case. Okay. So just to select export button. Okay. And in a few seconds, the system is calculating this mapping. If the app is not finding any issue, we can, let me go to desktop, for example, and then the name of the project is the same. So I will say this is room 0101, for example. Okay. So I have exported one file, and then we get a message. Okay, it's successfully finished. We can import now this file in the BMS platform. It's very simple for us. You just export and then we import. So I will say exit. Thank you. But as we have 8 different rooms, what I will do now is just to adapt my project with this name of the room and just to change the name of the gateway and the IP, because it's exactly the same physical and group addresses program in these devices. This is the only thing I have to do is this. So go to export, and then I will have the file for the next. It will be, in this case, room 0102. And if I do this 8 times, I will do just 4 times, for example. So, for example, the next one is change the name of the room because of the lamps module. If not, lamps module will be used. It's not important, but in this case, I have it under consideration. And just to change the IP according to the real IP that the devices has, that I already know. Just to export, and if you have exactly the same configuration, it's very easy. You don't need to have 8 copies of this project, just export it 8 times. So this will be room 0201, and I will just do it for the last time. I understand that you are you have been informed how to do this with 3 or 4 times, and that's not necessary to do it 8 times to show this, but it's exactly the same, just to do it 8 times. I will tell you afterwards that there is another possibility. We can do this also very easy using Excel. So, but it will be explained afterwards. So we have just from ETS point of view, it's easy, very easy for us just to select this, export this information, and then you will have all these files configured here. So I have all these files in the documents folder, also stored. I did it some days ago. So I have all these files. We can close ETS then. So we don't need to open ETS now. We just close it. And what I will open is the BMS Core Studio. When you install the BMS platform, you will find some icons. So mainly important icons are 3. One is the Core Studio. So this is the integration tool, the tool that has the item tree and all this, all the configurations you will see. So you will have different icons, as you can see here. Core Studio. You will have the web manager for this managing of all the items. Let me just say yes to open this, because it's a service that I have to give administration access, administration rights. So this core is the tool that we will use the whole training, and you will have, it's the most important part of the BMS platform. It's opening now, and I will create a new workspace, a new platform from the scratch, from zero. So you will see how easy it is to have our project included. It's opening in a different screen, so I will just move it to the screen we are sharing. Okay, this is our Core Server Studio. Let me just create a new workspace. Like the date of today and training. This is the name. It's very easy then to find in all the projects I have if I use the date. So it's a new workspace. This tool has a lot of screens, but we will focus in the center part of the tool, where we will have the item tree and all the configuration tables. It's very important. We will have, remember, a lot of protocols where this software is connected to. KNX, for example. So we will have to inform this software what are the gateways, what are the group addresses that are inside or beneath these gateways, group addresses or group physical addresses in terms of KNX, for example. And this will be that mapping are represented in different configuration tables that are very easy to handle, to manage, really easy to handle. In terms of other protocols like BACnet or Modbus are the same way. We will have devices, we will have data points that are included, mapped inside these devices. The way to integrate the different protocols will be different because that protocols are always different. For example, Modbus is totally manual. It's vendor-specific protocol. So every single vendor, every single manufacturer will do the mapping totally different way. So we have this Core Server Studio. We will focus now in KNX menu, okay? KNX menu. The first option is to import NETx ETS app file. So it's what we have, the different files. We also have different settings here. I will not lose time with this. But we will have also different tables, for example, objects, it's empty, object definitions, and it will be empty also because object definitions will be empty because I didn't export this topology view, this buildings view, etc. I didn't export it, so it will be empty also in the future. But we also have gateway definitions, for example. Gateway table definitions is empty now, just to show you. There is no Telegram, means group addresses. Telegram definitions, this is the most important. Table is also empty, just to show you that the project is totally empty, okay? Devices, no physical address definitions. And there is some dummy in the group alias. I will explain what is the group alias. There is something here, I will delete it. Not interesting in this, okay? So these tables are empty. So just to show you that after the import of all this information, very easily we will have all the configuration for my 8 practical devices. Just starting from the ETS project, I just need to import these files. So let me go to import ETS app file. Okay, we are reminded to restart the server after the importing. It's taking some seconds because my computer is full of tools open, but we have this screen here to import, very easy, okay? And then we have the reminder behind that you have to restart the server, okay? So just to select the file, okay? Okay, we have in documents all these files, as I told you. So we have these different rooms with NXC extensions for all these files. So I will just select one by one. But it's very important here, okay, what to do, replace or update. For the first project is exactly the same because replace is just substitute everything. It's empty, so just it will be just adding information. Update is to add information. So for the first, it's exactly the same. But for the rest of the projects, we'll need it to select this. Update definition, please do not replace the first room with the second. No, I want to have both rooms in my project. Okay, just a comment. For this, it doesn't mind, but for the rest of the devices, it will be needed to be updated. And do you want to import just the KNX data or the LAMPS data? Or both in this case? Why not? Import both, just to do this. So I just select start, and it is taking information from this file we have exported from KNX, and in a few seconds we have this import finished successfully. I say okay, and I will do the same now for the rest of the files. It's very easy. Okay, I want please to update, to add for this second room and the rest of the rooms. So we have to do it just very easy, and it takes only a few seconds, but we have to do it 8 times, okay? Because we have 8 different projects, we can say, independent projects, but for us, it's the global vision of the project that gives us this integration. The BMS is using the tunneling connection for this, okay? Next one. Just a few seconds, and they concentrate in the importing. It's just 5 seconds per room. Third floor, first room. We finish the third floor, so we go to the last one. Okay, I think I have finished. Yes. No more. I close this and I say, yes, I will start. So just before starting, just to show you, what do we have now? We have a table with the gateways, with the different gateways. So it has been imported 8 times, but it's okay. It's the 8 gateways. In this case, they are native KNX Net IP tunneling, but it could be secure KNX Net IP tunneling. Also, we can use KNX secure, or even the routing. It's possible to have here with a different IP. Of course, it will be the multicast IP in the case of routing. But no, normally we just use tunneling. Okay, the name of the gateway. If you don't have name, it takes the IP. Okay, by default. By default, takes the IP. But normally, it use the name as the part of the item ID. The identification for every item is this way. This is a table for the gateways. What happens with the group addresses, with the Telegram definitions? We have all the mapping here with some things that are not active. This is a differentiation between an item that is active. We see the different columns and rows, but some rows are in gray color because they are in commented mode. Maybe because there was some group address definitions in the project, but not physical device inside the project. So maybe, but this is automatically done by the ETS. And we have hundreds of group addresses, and the second column is the gateway. So this is the mapping I mentioned before. This group address is behind this IP represented by the name of the gateway. A lot of other columns that I will comment afterwards. So they're very important. Just importing, and we have all these device definitions. What happens with the device? They are not active. They are commented because maybe you need or maybe you do not need this integration. So you can convert to definition if you want. This is very interesting because you can work with items, or you can say, I am not interested in this item because these items will spend license data points. So will spend tax. The license are in terms of data points you are using. So if you don't want to spend data points, you may say, I'm not interested, but I will not delete these items. You can delete the items, but it's not necessary really. You can just put them into sleep mode, we can say, or maybe you can wake them up again. So it's very easy to understand what is a definition or a comment for an item, okay? And they are sleeping or in definition mode, so converted to definition. This is the physical address definitions that are also included in our, we can order by columns. They are included in our BMS platform, possible for the traceability of the system. So you have seen that just importing, and that's all. It's very easy. So what to do? Okay, let's start. Let's see this in the item tree, as I showed you before. And let's play with these elements. So let me turn on the camera, maybe, so you can see these practical boards. Let me turn on the camera. Okay. The BMS is starting, so we are, normally it takes less time, okay, to do it, but okay, let me show you the practical boards. And after starting the server, we can play with these elements. We will have the control, the total control of all the lights and shutters in the room. Okay. So the camera is also starting. And in a few seconds, I guess we will have it visualized. Okay. Takes a bit more time that I would like, but we will see the item tree. So you can see the practical boards there. And after the studio will start and offer us the tree, we will play with this. Also, it's very important, and I will show you this Telegram definition table also, because we have to work with this in terms of define what items are we need to read on reconnect. This is very important because when you have installation and the system starts, the system needs to know what are the temperatures, what are the status of the lights, the status of the shutters, all these things. So it's very important for us to understand how to do the software, get all this information from the very beginning. This is typically called the read on init, but in terms of BMS and NETx automation is adding more degree of sophistication. It's not just on init, but also if you lose a partial connection, for example, one line is disconnected and reconnects, the system is understanding that this is happening and trying to ask specifically all these items on reconnection. So this is the reason that this column is called read on reconnect. Okay, not just read on init. Let me check. We can, yes, it's starting. We have a tool that it's the BMS Plattform service control. As you can see that the server is starting, it is taking a bit of more time than that expected. It normally takes some seconds, but my computer is full of tools open, so it takes more time. I will try to improve this for the next times. So what we can do now before the system is starting is to work with this table. So we say, okay, we have, for example, the wind alarm. So this item is very important to read on reconnect. The column by default is F means false, it's not reading this item on reconnect the server. But if you are interested, you have to change to true. Okay, so for example, temperatures of whatever have to be changed. But imagine that we have hundreds of elements, almost 1,800 something. So it's complicated to do this one by one. So what we have to do is, or we can do, is to send to Excel this file, send to Excel. That is very easy. We just send the file to Excel and then open this. Is much simpler than, and working Excel is much simpler than doing this one by one element. Okay. Now it's finally started. Should takes much less, but it's a question of the computer. And now I will see some comments. Change your computer, Julio. It's time to change it. But I'm very happy with my computer. But so you can see here the item tree, as I mentioned you. This means that we are perfectly connected to all these elements. Okay. Every single room is included with the configuration. Okay. Some apps that are giving me some message, but everything's working fine. So I have, for example, every single room connected. So I can show you, if I have some main functions for the lights, for example, of this room, I can show you that it's working fine, just possible to test. Okay, I have sent, as you can see in the image, a central on for this first room 0101. Look at what is the room I am connecting is this one, room 0101. If I select, for example, room 0402, you can see the gateway. It's telling me that it's connected. It's true. That is also supervision of the gateways possible. The devices present because I didn't change the configuration here. Device definition was changed, but I didn't save this configuration. If I save now, it has to be restarted, the server. I don't want to restart the server because it took a lot of time. I will do it once I am managing the Excel file, okay? But it's not interesting now. But the question is, for example, if I want to do the same with the room 0402, just to show you that I have also the possibility to have a central off. In this case, if I send one, it will be a central on for that room. So I have just exported 8 times a single project, changing the IP address, and this is the configuration we have here. Okay, so it's very simple. It's very simple. We have the control, and we are just getting information, for example, for all these elements. And then we just have to check what is happening. For example, in the Telegram definitions, we will have to check if the data points are correct coming from the ETS. It's a responsibility of the ETS project, but it can be different, okay? So we will have to check all this. Let me export the Excel files to show you this working. I will close the camera now because it's not important and it's making slower the performance, but this is the way that we integrate KNX. Okay. So we have our Core Studio. In terms of KNX Telegram definitions, we will export to Excel. Okay. For example, and I will open Excel, open the file directly from here. I have it in another screen, and I will put it here. This is my Excel file. So it's very easy because you can filter, for example. You can have this file. Okay, this is exactly the same file that we had before, but you can filter. You can say, okay, it's interesting for me to filter by name, for example. Excuse me, but my Excel is in Spanish, but you understand. So for example, to say, it's very important to me that the status, example, status have this read on reconnect in true mode, and you do it very easy like this. All these elements, all this text that has status or temperature or whatever, it's very easy. I've seen that the first I did it before, but it's very easy for us. So if you have a list of words, luminance, for example, I want to ask from the start. Of course, if you have a cyclical send of this signal, later or sooner you will have the data freshed. But it's important to trigger this read on reconnect in some cases. You don't need to wait the status of the lights to change to get it, because sometimes you have to wait months to get a status change. Alarms, for example, wind alarm or whatever. Well, okay, this is just alarms, or maybe fault, for example. Fault, typical. It's also a lot of elements that it's interesting to read. So this is just first approach. A second thing, maybe we need to check is the data type, for example. This is a typical thing that has to be checked also. For example, in terms of KNX, there is a lot of elements that has the data type, and some of them are not correct. For example, the percentage is not this data type. It has to be scaling. So if you have this, maybe we have to filter again by name. And if the name contains percentage, for example, in the name, we have to exactly respect this. And change this. It's important because in the visualization, the scaling of these items are necessary. So it's important to have to check this properly, okay? Also the temperature. If you have the temperature, sorry, temperature. This data type is not correct. It's not correct. This is because in the ATS, it hasn't the right data type. So the data was not properly represented. It's important because there is a range, there is a configuration of the data point that is giving us the right information, and that's all. When you finish, let's say that we are finished. Let's delete the filter. Okay, so if you finish, just save this file, go back to the BMS. Sorry, let's go back to the BMS and say in for this table Telegram definitions from Excel. From Excel in the desktop Telegram definition, you just take the file with the proper configuration for KNX. We want to change the data. We want to restart the server. Okay. Save all. Okay, we have to start the server. So then, after restarting the server, that I guess will take much less, as you can see. Then in KNX, we are having, for example, imagine the status of the lights. We get the values correctly. The red items are just for the DALI simulated devices, so it's normal data from this, for example. Okay, so we are asking, and as you can see in the top right window, there are a lot of out and in telegrams that are for read and response. So you have a lot of read, response, okay, write, read. So the BMS is asking a lot of elements. What is the status of the whatever things, so the lights, the shutters, or whatever. So main functions includes the temperature that when we get the data, we will get the right value. It's not corrected. Okay, maybe I have to change this. Okay, next Telegram definitions. I have to check this. But the question is, with just these tables, we get the mapping of all these elements. And finally, and we can stop for the next session, I will show you what the broadcast driver means. In this case, the broadcast is interesting, but because we have a unique installation, and maybe we need to send a central function to all the elements included in the floors. I mean, for example, we have eight rooms. It's a hotel, so it's not typical to send a central on or central off of all the rooms, but imagine that it's important to send a central on for the lights, for example. So, but we have not routing, no communication between the lines. So it's, in terms of KNX, impossible to do this. You cannot send from one line a telegram to the rest of the lines. But we don't have only KNX. Remember, we have a BMS connected to all the installation. So the broadcast driver is helping us to do this job. It's possible to define one item that you have configured in the, of course, in the actuators. You need a specific group address that it's also configured in the actuators, and do this job. Send a telegram that will the IP tunneling connections simultaneously. It will send to all of them. We have one light in these main functions, lights. So you can see we have a central group address that is 010. So you see the item ID here. The group address is this, 010. 010 is for the all rooms, not only for this room. So every room has this, all the devices has this configured, but we need to define it for the broadcast driver. So let me go to the definition table and try to order this by group address, okay? So, and then select all the elements that are broadcast, for example, the sync control, let's say. These are broadcast. So I will not delete, but just put this in comment, and instead of room, I will say broadcast, for example. This is not interesting. Sync control, another one, because we are using two address for scenes, one to run, one to reproduce, but broadcast again. And this central off, and this one will be, I will not delete it because it's, I'm sorry, this also may be interesting to take it back again, but I will just put into sleep all except one, and then this one, put it in broadcast. These are for single rooms, so this is not interesting. Central value for all the rooms, so to send all the dimmers to the same percentage is also interesting. Broadcast. Nothing. Move shutters for all the rooms. So only a few of these elements defined in the broadcast driver. Broadcast. Okay. And this is for the room, and this is the central stop for all the rooms. Okay, this for broadcast again. And I finished with this. All rooms, broadcast. If you are using IP routers, it's not recommended to use the broadcast driver, because the broadcast is inserting in all the lines the signal, the telegram. If this will provoke the bounce of telegrams between lines, that is not possible now because we are using only IP interfaces. But with IP routers, do not use the broadcast, okay? Because it's not recommended to have all this traffic. So the broadcast driver also will have in the group alias definition, that is for the name of the main and intermediate group addresses, it's also important to consider this. I will do a copy paste of this. For the past. I will show you afterwards, because we need to have the name of the main address and the group address, main and intermediate group address for this. So I will do this. Okay. And save all that is forcing me to restart the server again, and you will see the result, and we can finish this first session, and we will continue with the next session, including BACnet, but also checking all these configuration with KNX. It's interesting to show you just the broadcast, how it works. I will close this and just wait for the item tree to restart again and open the camera and show you the result. Okay, so you will see. I will place the camera better afterwards, because I guess you don't want to see me. But you will see only the practical boards more near, and so we wait for this restart of the BMS, and then you will see the broadcast driver working in a proper way. So as a resume, you can see in the Core Studio different windows, but the most important is the central part, because you will see the item tree here, and you will see also the table, the configuration tables for KNX and for BACnet or whatever protocol you may have to integrate. But also important, the Telegram monitor, where you can see also the traffic, different protocols also. The properties, the item ID and the properties of the items, we will see a lot this again when we do some complex integrations and some scripting, some XLogics and all these things. The system message is also important. Also, everything is being recorded in different log files, and everything is here in the system message on the fly. Cells is to supervise specific items. If you are interested to have a specific item always supervised, you can add it here in cells. I normally don't use it a lot because the supervision is not made here, is made in different visualization softwares and also the vision for the gateways. You will see here afterwards that we have a KNX and BACnet and Modbus and a lot of things, SNMP, whatever, the native drivers, so the gateways are here also. So finally, this explanation, I will just show you. Okay, I have main functions, all the rooms, lights, brain chatters. Thanks. The names here are appearing thanks to this group alias. Okay, the definitions. I did this because I needed to have these names, because if not, it will have no name. Okay, but just to explain you what is this table for. Group alias definition. So let me close this, and then again, item tree. So if just in broadcast driver, I have this central of lights, and I just send 0, you will see I turn off this practical board because it was the only one that was off. But if I send 1, what the system is doing is boom, sending the order to the all gateways. Okay, so it's really nice. There's some failure in the first dimmer behind, but it's working fine. So I say 0. I am attacking all this at the same time. The first is doing some delay, but it's because of the load is very low, and the shutters, you can attack the shutters to move, for example, all the shutters up, and all the shutters are now moving. You cannot see that because there are no shutters, but there are. So just, and if I want to stop them all, I can do it with this. So it's very simple to supervise what is happening, and also to have a special function like the broadcast driver. And finally, I promise, the final thing to show you is the devices that you can see if we have devices or not in the present in the practical board. So you can see, for example, here every single device is present except the DALIs that are for simulating things. So we finished this this first session. So remember to subscribe to the next sessions if you want to continue to understand all these things. And we will be back again in half an hour in this case. Okay, so in the chat, we have in the principle, in the beginning of the chat, this link. Maybe my colleagues can also now in the chat. I'm stopping the recording and then starting again in half an hour. So thank you very much. In the next session, we will see backnet integration also on Modbus, I think. So let's see in half an hour again. Thank you very much and see you.